So today we're going to look at section 6-2, rational exponents. And we're going to start off with the index. So the index is the small number to the left of the radical symbol that tells you which root to take. For example, 3 here is the index, and it represents a cube root. We're going to use this knowledge here to look at the definition of b raised to the 1 over n. So b could be any number or variable. It's just your base of your power. Remember that a power would look like this. So a power would be, for example, 3 to the 2, where 3 is your base, and then the 2 is your exponent. So that whole thing is a power. So instead of our exponent being 2, we're going to have an exponent that's a fraction. So looking over here, 3 to the 1/2, the bottom number 2 really means what root we're taking. So since the bottom number here is 2, we're taking the square root of 3. Our base is 5, so notice that the 5 is under the radical. The denominator of the fractional exponent is 4, so we're taking the 4th root of 5. Our base 2 goes under the radical. The denominator in that fractional exponent is 7, so we're taking the 7th root of 2. Now how do we simplify these powers that have a fractional exponent? So as we look at 36 raised to the 1/2, the 2 means we're taking the square root of 36. So let's go ahead and rewrite that. So we've got the square root of 36. And all of you should know what the square root of 36 is, and that's 6. For example 2, our base now is 125, but the denominator has changed in that fractional exponent to 3. So we're going to take the cube root of 125. So it would be handy if you prime factored 125, and so 125 prime factored would look like this: 5 times 5 times 5. Because we are taking the cube root, we want to get any groups of 3. So the cube root means you're finding groups of 3. So I can only make one group of 3, and so my answer is going to end up being the cube root of 125 is just 5. So that means that 125 must have been a perfect cube, just like 36 was a perfect square. Then you're going to have some problems where you have powers being added to each other. The bases are different, and their fractional exponents are different. So just treat them as separate entities. So for instance, we're going to change 64 into the 6th root of 64. So we've got the 6th root of 64 plus 25 to the 1/2 means we're taking the square root of 25. So 64, if you prime factor that, it actually has 6 2's in it. And then the square root of 25 is just 5. So since we're taking the 6th root of 64, we want to make groups of 6. So I can only make one group of 6. So that means that 64 must be a perfect 6th. And my answer is 2 plus 5, which is equal to 7. The last example in this section is the 4th root of 81. So let's go ahead and switch that out, or convert it. And if you prime factor 81, it has shocking 4 3's. Because we're taking the 4th root, we want to make a group of 4, and so our answer to the 4th root of 81 is just 3. Now for right now, these happen to be working out to be perfect squares, perfect cubes, perfect sixths, and perfect fourths. It won't always be the case, so just don't get used to that. I think that's it on this page, so let's go to the next page. Alright, so what happens if we no longer have 1 over n, but we now have something other than 1 over n, like 2/3 as our exponent, or 5/6? How does that change what we just did? So let's look at some examples. We've got 8 to the 2/3. So this denominator 3 hasn't changed what it is. It's still the index to your root. So our base 8 goes underneath the radical. The 3 is our index to our root. And then the 2 is really what we raise the base to, or the entire root to. These are identical. You can either take the cube root of 8 and then square that answer, or you can square 8 underneath the radical and then take that cube root. So the question is, how do they get 2 squared? So remember that 8 has 3 2's in it, so the cube root of 8 could be rewritten as 2 times 2 times 2, and then we would want to square all of that. So because it's a cube root, we want to make one group of 3's, or however many groups of 3's we can, which is how we got that base of 2. And then we're squaring our result to the cube root of 8, so that's where 2 to the second came from. So 2 squared is 4. If you wanted to square the base instead, you would have 64, and 64 is going to have 6 2's in it, just like we talked about before. So if we have 6 2's, we've got the cube root and because we're taking the cube root, we want to look for groups of 3, so I can actually get 2 groups of 3. So this is going to end up being 2 times 2, because every time you circle a group of 3 here, you pull out a 2 for each of the groups that you were able to make. And so then you have to multiply those together, and that's how we get the answer of 4 there. So let's look at some actual problems where we're simplifying. So we're going to simplify 216. So let's rewrite it in radical form. Let me find, let's try brown and see how that shows up. Oh, not bad. So we're going to take our base of 216 and put it underneath the radical. The 3 here means we're taking the cube root. So we've got the cube root of 216. And then the 2 in the numerator means we're going to take the whole entire thing and square it. If you don't want to do that, then you could just put the 2 here and square 216. I'm choosing not to do that because it's going to make 216 a really large number. So let's go ahead and prime factor 216. I don't know off the top of my head exactly what's in there, but I do know that 216 is divisible by 4 because 216 ends in 16 and 16 is divisible by 4. So I'm going to start out with 4. So that's an ugly 4. So 4 goes into 21 5 times with 1 left over, and 4 goes into 16 4 times. And so then we've got 2 and 2. And 54 is 6 times 9. So that gives us a 2 and a 3.